Good morning, guys. All right, so today we are going to take a look at the last of the three ways in which you can solve a system of equations. Okay, so remember, up to this point, we've looked at the idea of graphing a system. So we're visually looking for the point in which the two systems create a shared value, a shared ordered pair. Then we looked at the idea of substitution. Remember our rules for substitution? We needed to solve or have an equation solved for a given variable. And then from that point, we could substitute or plug it into the remaining equation. All right, today we're going to look at the last of the three options. Okay, and that method is called elimination. Personally, it's my favorite of the three. However, each of them I think has their own weight and value of when they're the most important. So we're actually going to look at this elimination. We're going to look at it in two parts. Today, we're going to look at it solely through the use of addition or subtraction, okay, which, disclaimer, probably the easier of the two options for right now. All right, and then tomorrow we're going to look at the idea of using elimination with multiplication. So, kind of talk about how that setup goes. Ultimately, no matter what we do, the goal will be to bring it back to something like what we're going to see today, and then use this strategy of elimination. Okay, so as you take a look at this here, we're really today going to stop after we get to the second example. All right, and you're going to have a Google form tonight that solely deals with addition and subtraction. All right, and you're going to be asked to put the ordered pair in that they share in common. Okay, this is going to be our first Google form where you are not given multiple choice answers, but where you're going to need to input your own answer. So when you do that today, all right, every ordered pair that you put in is going to be some x comma y. Okay, but in this situation, there will be no spaces in between what you put in. Okay, if you put spaces in there, then your answer is going to appear to be wrong. So if you think the ordered pair that they share in common is 3, 4, then it's going to be parenthesis 3, comma 4, close the parenthesis. No spaces, or it's not going to record your information correctly. All right, so our goal today, can we use elimination with addition, subtraction, multiplication, like I said, will be tomorrow. Okay, so here is what elimination looks like. Okay, it's another method, okay, to solve, but it's got a little bit different of a setup. And so that's why I told you guys last week, listen, if we don't have a single variable that's solved, so for example, if we just jump off of here for a second, if you had an equation that looked like this, x plus 3y equals 12, and then you had another one that said 2x minus 4y equals 8, this might not be a bad idea to use substitution because I have a single variable right there, right? I could just simply move the 3y to the other side, I could box the result, and I could plug it in where the x is. But if there's a value in front of this x, like let's say, there's a 5 there. Well, now you're talking about having a different problem that maybe requires a little bit more work. And so here, it might be better off to use a different strategy. And in this case, we're going to talk about the strategy of elimination today. So elimination gets its name because it's going to do exactly what it sounds like. It's going to eliminate, or it's going to cancel some coefficients. So here is the big key today. All right, to determine whether, and we're looking at this statement right here, to determine whether any like terms can be eliminated, they have to have opposite coefficients, okay? If we have opposite values, we can make them cancel each other out, meaning coefficients of like a positive 3 and a negative 3. If we put those two together, they would cancel each other out. So the rules for elimination, there are 4 of them. Rule number 1 is not solving for an equation like it was in substitution. Rule number 1 here now is that we have to have them lined up. Okay, so think like standard form, ax plus by equals c, kind of lining them up on top of each other. In fact, if you look at this example that I just created, they are aligned. Notice that your x values are lined up, your y values are lined up, okay? And so we're going to try to use this method. So step number 2, we're going to eliminate one of the variables. Now we can't just cross them off. We have to make them cancel off. We're going to use that idea of opposite coefficients. Step number 3, we're going to substitute back in so we can get our other one. Step number 4, we're going to write our answer. Okay, so the last portions, 3 and 4, are going to sound very familiar to substitution, except now we're going to be looking at them with the idea of elimination. So I would ask in your notes that today, even though we're ultimately going to need 3 parts because we're going to finish this tomorrow, part number 1, example 1, is going to use the idea of addition. So in your notes, please make note that this is using the idea of addition. Okay. So if you look at this problem here as you're writing this down, okay, we already have them stacked. All right, they're vertically aligned. The x's are lined up, the y's are lined up. Okay, and then the constants down here at the end, they're also lined up. So one, it already is kind of set for elimination. But then secondly, notice that if you see those y values right now, they currently are opposites of each other, a -4 and a +4. So when we say using elimination with addition, notice that if I simply take these two equations and I add them together, what's going to happen? Well, if I do 3x plus 1x, I get 4x. If I do -4 plus a +4, those cancel each other out. And if I do 10 plus a -2, I get 8. And I quickly can see that my x value is worth 2. Okay. Now, in order to find my y value, I'm going to take this value of 2, I'm going to plug it back into one of these two original equations. It doesn't matter which one you choose, though my opinion is that I usually pick the one that looks smaller. So for me, I'm going to pick the bottom one. So if I took the bottom one, I would have an x value of 2 plus 4y equals -2. And now I'm just going to solve it. And once I do that, I'll know what my resulting y value is. So I divide both sides by 4, and I find out that y is -1. Boom, got my ordered pair, 2 and -1. Okay, now obviously this one looks super simple, but that's because of this statement right here. My y values were already opposites, and because they were opposites, I could simply add them together and they canceled out. It's not always going to be that simple, but the goal is to make it become that simple. We'll see that more tomorrow. All right, so let's look at one more of these, and I'm going to ask, after we reveal it here, I want you to go ahead and pause your video for a second, and I want you to think about how you're going to solve this, okay? We're going to use addition. So if we set this up, we are going to use addition again. So go ahead and pause that right now. Go back and look at the first one and see if you can't figure out how to get this answer. Okay, so hopefully you've tried this. Okay, if we add these two together, and again, we're going to add because those two x values right there are going to eliminate each other away. We will be left with 3y, 1 plus 2. The x's cancel. And on the other side, we have a -2 and a +14. We get 12. We divide both sides by 3, and we get a y value of 4. Okay. I think I will take, again, the top equation. Nope, it's not equal to 3. Sorry. Y is 4 plus 3x equals -2. I'll minus that off of there. I get 3x equals -6. I'll divide by 3, and I get x equals -2. Boom, there's my ordered pair. Okay, so in the bottom of your notes, okay, if I am solving by elimination with addition, all right, it's because I have opposite coefficients that cancel when I add. Okay, that's important to remember. And we're going to have the exact same statement over here in a minute. We'll bring this one over here, except we are not going to say addition. We are going to say with subtraction. All right, and we'll make a statement about that here momentarily. But if we go back here to the addition piece, I am going to add, because in both of these examples, okay, right there, opposite coefficients. That's why I add. Come down here to this one, opposite coefficients. That's why I'll add. When I see two things that are opposite, if I add them together, they cancel out. All right. The other piece we're going to look at today is the idea of using subtraction. Okay, so here, I don't want to add these together. If I added 2 plus 2, I would get 4. Not helpful. Not if I'm trying to make something go away. Now, in this situation, I'm going to subtract because those two values are exactly the same. So if I do 2 minus 2 this time, they will cancel each other out. Now, you do have to be careful with subtraction, though, because in this situation, notice I have 1y, and I'm going to minus 5, a negative 5 from that. So when you minus a negative, you actually end up adding. So here I will get 6y is equal to negative 5 minus 13. That is negative 18. And if I divide both sides by 6, I get negative 3. So I get a y value of negative 3. Okay, choose whichever one you'd like to put it back into. I think I'll choose the top one at this point. So I'm going to add a y value, which is negative 3, and that's equal to negative 5. So here I will add 3, and I get 2x is equal to negative 2. So obviously then x is equal to negative 1. Okay, so here adding was not the right idea, and this should be example number 2 in your notes. Okay, example 2, because here adding two things that are the same doesn't do it for me, but subtracting them does. If we take a look at this one down here, okay, again, your goal is to get something to eliminate, to go away. All right, and in this problem, hopefully you see right here that those two values are exactly the same. So subtracting them from each other will cause that elimination to take place. Okay, if I do that, 3 minus negative 2, minusing a negative again turns into a positive, so that's 5x is equal to 15 minus negative 5 is actually 20. So I divide both sides by 5. X is equal to 4. Okay, get x value of 4. I think for this one, I'll choose the bottom one. It looks smaller. So negative 2 times 4 plus 3y equals negative 5. That's negative 8 plus 3y equals negative 5. I will add 8 to both sides. I get 3y is equal to 3. So y is equal to 1. All right. Okay, so if I come backwards this screen right here, solving by elimination with subtraction, okay, if I have identical coefficients, okay, then subtracting will cancel them out. Okay, so subtracting in this case will cancel them out. Not adding. Adding would double two things that were the same. Subtracting will cancel two things that are the same. All right, so we are going to put a stop here, and we're going to practice this idea, okay? Moving forward, you can see here that in this example, nothing is ready to cancel out. That's why we're going to have to multiply something first, and we'll get into that idea more tomorrow. But today, I want you to practice two things. I want you to practice when I see things that are exactly the same, using subtraction to cancel them out, okay? Or if I see things that are opposite of each other, adding them is going to cancel them out. All right. Elimination provides you with a quick answer in your first one, and your second one will require a little bit of work. It's a little bit different of substitution. In substitution, the first one required work, and the second answer came for free. Okay, so like I said, tonight it's a Google form, 10 questions. You have to put in the ordered pair, no spaces in that. All right, message me if you guys need help. Talk to you later. Bye.